Good morning, good afternoon, good evening, everyone. I'm Asanka Abeysinghe, Chief Technology Evangelist at WSO2. WSO2 is a technology company that we are providing core technologies for digital transformation, focusing on API management, integration, and identity and access management. If you are interested about WSO2, I have put the URL in this slide. You can go there and take a look. So before jumping to the topic, I would like to give a quick introduction to myself. So I'm coming from a strong product engineering and product architecture background, then moved to the solutions architecture side, mainly focusing on customer-facing technical tasks. And then I moved to the CTO's office. There I authored the reference architecture that we are going to speak today, and then reference methodology. Now, as the chief evangelist, I am telling the WSO2 story in events like this and various other forms. So I'm strongly contributor. I am a strong contributor of open source. I'm Apache commit as well, and working on the distributed computing technologies, and as a middleware developer and architect for more than 2 decades now. So that's a quick introduction about myself. So during next 40 to 45 minutes, what I'm planning to do, explain you about these 3 things: why I created a new pattern, and then how I created it, and what it is. So I have put the URL down. This is the complete specification released under Creative Commons. So feel free to comment, provide feedback, send a PR or criticize. So your feedback is welcome, and I really appreciate your contribution to this effort as well. So I usually get invited to many architecture conferences to speak about this topic because it's a timely problem that we are trying to solve here, as well as a lot of architects are looking at this problem. Before pandemic, when it used to be physical events, I usually get this type of feedback from the audience. They are looking at me. They came to the room because the topic is interesting, but they are kind of giving me a look whether this guy is smoking, because the architecture patterns are well defined today, and then people are getting a lot of benefits from the architecture styles available. So the question in their faces kind of resonate that why we need a new pattern. Actually, I wasn't smoking. So we had a couple of really good reasons to come up with this new architecture style. The first motivation factor I identified is the mismatch, because architects are having a specific need and expectation from the reference architectures, but then again, what is available as reference architectures are providing slightly different things. So there was a mismatch in this space. So that's why, as an architect who was contributing to these open standards and community, I thought of introduce this new architecture style. So the first motivation factor, the existing architecture styles are centralized and layered. Because of this nature, the centralized and layered nature creating gates in between different architecture layers as well as teams. So gates are blocking the free flow of the productivity, and then that is bringing us back to this waterfall agile type of methodologies rather than being completely agile in our development environment. So this was the first motivation that I had. We need to find a way to break this centralized nature and layered architecture available in the market. Second thing is, if you talk to an architect, the architectures defined by most of the architects looks like this in the picture, using the modern technologies, very clean, very aligned. So I call it as a PowerPoint architecture. Why I call it as a PowerPoint architecture? Because if you walk into an enterprise, it doesn't look like this. It looks like this, because we have certain amount of data and certain amount of systems that we purchased during last 2 decades inside our organizations. We can't just avoid them. We can't just overwrite everything in a day or two. We need to deal with this data and system to service our customers. So as an enterprise architect or a solutions architect, you might be in a position that you have to leverage the existing stuff while you are building new applications on top of that. So basically, in every organization, we have the brownfield and the greenfield. And if you look at those two sides, the brownfield is larger than greenfield. So the existing architecture styles either addressing one spectrum of this problem, either it's addressing brownfield or either it's addressing greenfield. So what I thought, we need an architecture style which can address both of these spectrum, which can use to build brownfield applications, connect brownfield with greenfield, and then build new applications using greenfield technologies and platforms. In this, the next motivation I had while doing this research, I identify most of the reference architectures are not reference architectures per se. Why I claim that? Because most of these reference architectures are built based on a specific technology. And then if you look at it deeply, it's bound to a specific vendor technology as well. So I call them as reference implementations because it's using a specific technology and a specific vendor product. So in my opinion, a reference architecture should be technology neutral and vendor neutral. So that's another motivation I had while working on this paper. Then if you walk to an enterprise, and you will see the underutilization of technology a lot. It is just like you are keeping your best players on the bench while the game is losing. And I hear this thing when I talk to architects. We have a Kafka message broker running, we have a Kubernetes cluster running, but then again, I can't use these technologies because my architecture is not flexible enough. So I wanted to build something that can utilize and optimize your current technology stack as well as your desired technology stack that you will bring time to time. Then another issue that I identify while working with this organization, there's a gap between architecture, development, and deployment. In other words, between the architect, developer, and the DevOps person, there's no common language, or there's no common thing that they can take from architecture into development and into deployment. As a result, what we are getting is architecture done by an architect, built slightly different by the developer, and then deployed completely in a different deployment architecture by the DevOps people. And then I wanted to look at a way that how we can connect these three user personas plus activities that we have in an application lifecycle. Then microservices. With microservices, it's kind of a mess inside these organizations. And if you look at this famous graph from Uber, that we call it as a microservices Death Star. Now with these decentralized architecture styles, you have a lot of moving components. So you need some kind of governance. The governance starts with the dependency management. So you need dependency management inside the organization to manage these decentralized distributed architecture components. So those were the key motivation factors and the reasons that I had behind while working on this new architecture style. So before we look at the new architecture style, let's look at the past, what's really happened in the past and why we are here with this new architecture style. So if you look at the timeline, we started with the monolithic architecture styles that user interfaces, business logic, and data were bundled together. And with the improvements of databases and data technologies, we move to the two-tier architecture style by removing the user interface and business logic from data layer. Then the most interesting era came, that is the three-tier architecture. Even I started my career during that time, that we had the user interface, business logic, and data separated. And there were a bunch of sub-patterns of three-tier architecture came that we used to call as model view controller and model view controller 2. That led to service-oriented architecture. That service-oriented architecture started wrapping the business logic with services and APIs. So that happened during early 2000. And there were a bunch of service-oriented architecture patterns came. Event-driven architecture, web-oriented architecture, 2 examples of that. Then around 2011, 2012, microservices architecture came into the picture, and now we are at this cell-based architecture. So what I want to highlight in this slide, we are moving from a layered and centralized architecture into a segmented architecture and into a complete decentralized architecture. So this is what really happened in the application architecture evolution. So this is a layered architecture that I drew some time back. Very productive architecture diagram that we built many systems. We had many productive discussions with many architects, and still some of these organizations are using this architecture diagram as well. And if you look at this is slightly different from a traditional layered architecture that I made it two-dimensional, that we have this system layers in one angle or one dimension, and then I brought the application lifecycle related components and quality of services in another dimension as well. So this is a typical layered architecture. So we were using this application style and building many applications, but around 2011, there was an incident happen. A platform built by using this particular architecture failed. After 3 years, they went into production, even they were using agile principles. So we looked at why they failed. If they are using agile principles, they should release these applications in a quicker intervals that we call as sprints, but it had not happened in that particular team. When we carefully look at it, even the team is been working in agile mode and following agile principles, architecture is not flexible enough. So this was an eye-opener for us. We thought we need to find a way this layered centralized architecture doesn't work anymore for agile development. Same time, microservices came into the picture, and many organizations started using microservices. But there were a lot of theory behind microservices. Then again, people who went into production with microservices, they had a common pattern. Netflix called it as the API layer. Uber used to call it as the edge gateways. eBay used this term called API facade. Even Gartner, after some time, they announced this service layer called mini services. So with this architecture style, what really happened, there was a new layer came on top of the architecture styles that they were planning to use. So let's take a step back and look at what is this business side of the services and microservices and technology side of services and microservices. So this is a technical definition of a microservice. It's just a piece of code that you annotate and then make it available across the network that you can access using some kind of a network interface. But business is looking for something different. It is looking for a solution for a business problem. When you try to build a solution, you need to connect these number of services. That's where a gateway or a composite service come into the picture. And if you look at the technical definition of microservices, what you are doing here, dividing that monolithic services into small pieces based on the scope, not based on the size. I will repeat it, it's based on scope, not based on size. And if you get into the code, you will see the same thing, that you will write some type of a code using a specific language, you annotate it and make it available as a network interface. To do this, you need to look at the business definition as well. And business doesn't care whether you are writing a microservice or a monolithic service. What business is looking for, some kind of business capability, so some solution for a problem. To do that, you need to again connect the microservices. If you have 5 microservices, you will not have this problem. But when it comes to 100, 200, 300, and 10, 100 or 1,000, then it will be a complicated problem. Then you have to connect these composite services. That's why even the people who started using microservices used to have some kind of a way to glue these microservices within the organization. So those days, the architecture looked like this. You are still fit into the layered architecture and then adding microservices as a layer. And some organizations, they extended this thing by having different segments, partitions inside the layers that we call as tenants. And it was an improved architecture. And I used to call this as a segmented architecture. And some organizations, they even use a different approach by redeploying the platform and having the shared capabilities, unique shared capabilities for each and every platform, that I call it as a platform of platforms. But if you look at those two approaches, still you are using a layered architecture and it didn't provide a solution for us. Then we thought of, okay, this layered and segmented approach doesn't work. We need to find a way to use microservices properly and then address the motivation factors that I listed at the beginning of this session. So we started building this concept, done a lot of research, but we narrowed down our research into these areas: quantum computing, Kubernetes, biology, and system biology. Why we pick biology? Because we identify cell is a basic structural unit in every living thing. So a cell is a really good way to describe and define enterprise systems, because enterprise systems are complicated like living beings as well. So that was our motivation factor. And with that, we define the cell-based architecture. And in the cell-based architecture, the atomic units, we call it as a component. Component can be anything. It can be a microservice. It can be a monolithic service. It can be a database. It can be a gateway, message broker, a function, anything that you run as a runtime component, we treat it as a component or the atomic units of this particular architecture style. Then once you connect these components, we call it as a cell, and the cells are the units of enterprise architecture based on this side. And if you look at carefully, each cell contains a cell gateway, and inside that you will have many components that inside each and every cell. And each cell is deployable and manageable as well. And if you go back to that concept we discussed, you have the microservices, but you need to connect a number of microservices to provide a solution for a business problem. Then that particular boundary, we call it as a cell, and the gateway or the composite service, we call it as the cell gateway in this particular architecture style. So the ratio between cell and component, in most cases, it is one to many, but there can be special cases that you have one to one. As example, if you are running a message broker or a database, then it's one to one. But if I repeat it, in a common case, it will be one to many. Now you have to connect the components and you have to connect the cells. So that's where the connected cells concept coming. And we are using the same, the common concepts like a management plane, data plane, and a control plane when it comes to the communication of the cells. And my analogy for these three is a train system, that the control plane is the train tracks that will kind of control the movement of the trains. An actual train that carry goods or passengers is the data plane. And somewhere you have a control center that is called the management plane. So based on these three concepts, like each and every cell contains a local data plane and a local control plane, as well as for the entire enterprise, you have a global control plane and a global data plane and a global management plane. So I call them as a local mesh and a global mesh. So if you are familiar with service mesh technologies, this is service mesh plus, because in the service mesh concepts, it's only one mesh that you have. But in this case, you have now multiple service meshes that acting as a local mesh and a global mesh. So the connected cells, there are some rules, like any ingress communication should come through the cell gateway, but the egress calls that is going out from a cell can go from a component to another cell gateway. So we can use sidecar, adapter, ambassador, those type of microservices and container friendly patterns to do this egress communication that help us to have a API first architecture as well. Because if you look at all these components will communicate using some kind of an API, as well as the capabilities that you are exposing from the cell will go out using an API. So these APIs can be many. It can be RESTful APIs using HTTP, gRPC, async API, or GraphQL, so on and so forth. Or it can be a push API like a JMS, AMQP, or SMTP. And then it can be a streaming API like Kafka or MQTT. So based on the nature of the capability that you can expose these using different type of protocols, or you can have the same API exposed with many protocols by providing different favors of the same API for your consumers. In the this gateway that we are using in the API, in the cell, creating a nice governance framework, because all the ingress calls are hitting the cell gateway. With that, you can enforce the policies, as well as you can collect observability data from the cell as well. Then the security of a cell is really important. There are two patterns. One is a self-managed security approach that entire decisions will make inside the local control plane. But in some cases, you have to go to the global control plane and get additional information to make authorization, authentication, or entitlement decision. So both patterns are valid. In the second pattern, we might have to cache some of the security decisions to make it more high performance. Then the developer experience doesn't change with this thing. Developer will either create a brand new cell, or they will connect existing set of microservices. They might update an existing cell, or they will create a new version of a component or a cell as well. And they will go through the same life cycle. They will write the code, build it, commit, test, and once the test is passed, they will push it to the remote repository, and that's where the CI/CD will kick in and deploy these components or cells. If you are in a container-based environment, you can always create a new cell and deploy, but if you are in a hypervisor-based environment, you might have to deploy the individual components as well. In case if you don't have CI/CD matured at this level, even a release engineer can start that or take over the CI/CD process and manage it as a human task by running a script or a deployment specification. In life cycle of a cell, basically each cell contains a version, and each component contains a version as well. So this creates additional agility for us that I call as a structured agility, that you have the agility at the component level, you have the agility at the cell level, and you have the agility at the enterprise level. So that way you have better flexibility and agility of your environment as well. Then if you look at the enterprise architecture, because now we looked at individual components and cells, but it has to fit into the enterprise. So it will looks like this, like you will have multiple cells running inside your enterprise. And we can categorize these cells into logic, integration, legacy, external, data, identity, and channel. And these are the cells that I identified based on the reference implementations that we did using this architecture style, but you can add more cell types as well. But this categorization can handle most of the implementations that we have to do with the current market or landscape that we have in the tech as well as business. And if you look at a reference implementation, I took example with the employee cell, order cell, and a customer. So it will connect to many other cells inside the organization. And if you look at each and every cell, expose these capabilities as APIs as well. So based on your business problem, you can define these cells. And a reference implementation, if you have moved to the level 1, what I want to highlight, this is a very technology and vendor neutral pattern. You can use any technology. I use some WSO2 components, as well as I use things like Spring Boot, Nginx, and many other SaaS and legacy applications available in the market. So it's completely vendor and technology neutral. You can pick your desired technologies. And this is a very human-centric architecture as well. You can build the team boundaries. The two pizza team or autonomous team boundaries can define with cells. The rule here, one team can own many cells, but a single cell cannot be owned by many teams. So that is the rule. With that cell boundary, you can nicely organize the team structure in your development or the organization. So I wrote a blog. If you are interested about this, you can go to this URL inside the Forbes Tech Council. You can read more about this cellular enterprise that I'm talking about. So once you implement this, or once you inherit this particular architecture style, there should be a way to measure the success, because business will not care about what type of capabilities that you are providing, or what type of technology that you are exposing through these different architecture styles. So there should be some kind of measurements that you should have in this architecture style. So the first way of measuring this is the flow efficiency. Since we are moving from a centralized layered architecture into a decentralized distributed architecture, what we have noticed, the efficient time or the efficiency is getting higher by making your productive time is higher than your wait time. In a typical layered or centralized architecture, the wait time is higher than the productive time. So what we have identified with this type of an architecture style, you are giving more flexibility and increasing the productivity of the team. So that way you can have a high efficiency. And then the autonomy that we are bringing with this architecture style increase the MTTR or mean time to repair, as well as MTTD or the mean time to detect. Those type of metrics will really helpful for you to show the impact that you are bringing from this particular architecture style. Then if you look at the summary of this concept, each and every cell, it's a self-contained one. And then we treat each and every cell as a unit of enterprise architecture. And each and every cell is independently scalable. You can do scaling at two levels, one at the component level and one at the cell level. And then each and every cell contains a local data and a control plane. So if you are mapping this concept into Kubernetes, a component is a pod, and a cell can be a namespace or a CRD in Kubernetes world. But then again, it's totally depending on how you define these concepts. And then again, the domain-driven design is a good way to define the cell boundaries that you can, if you define or design your system using domain-driven design, a subdomain can easily map to a cell and create these cell boundaries as an architect. Then if we summarize the cell-based architecture as an overall enterprise or application architecture style, it's decentralized microservices architecture, inherited and completely cloud native that you can deploy in a cloud native environment. And as I highlighted a couple of times, this is completely technology neutral, and this is human-centric because of the nature of the cell that can map to a team, and you can build APIs as products, and a cell can treat as a API product by using this particular architecture. And I explain how this is tied with APIs, and this is a completely API-centric or API-first architecture as well. So the contribution to these concepts, we have done it in many ways. The first thing is this specification that is available in the first URL, and it has multiple other architecture papers as well. There's a layered and segmented architecture for the people who require to use that, and then cell-based architecture there as well. In addition to that, I I released a reference methodology as well, because a lot of people question how I am going to implement this reference architecture. Then the reference methodology basically giving you a path or a guidance to implement the reference architecture, and it is available in the second URL. And then as an organization, we introduced this new cloud native programming language called Ballerina. And if you go to ballerina.io, you will find more and more information about it. So the role of Ballerina in this particular architecture, you can write components using Ballerina, like microservices, integrations, and it can play a role as the gateway or the API layer of your cells. And many other components that we have released under WSO2 can play a role here, as well as the API gateway, integration, as well as the identity and access management. Then we did a small project called Celery. It's available at celery.io, but not active project at the moment, because we wanted to try out this particular architecture style. So we created this sample project, and we did work on it. And if you are interested, you can go there and take a look at the Celery implementation as well. Then these are my contact details, that if you are willing to have a detailed conversations, you can connect me through LinkedIn is the best place, and Twitter as well. So I'm active on Twitter, so you can follow me there. And if you have any questions, feel free to ping me so I can help you on building this architecture that I'm providing consultancy on, like the architecture side, as well as the methodology on both cell-based architecture and the agile methodology. So if you need any help in your current projects or the projects that you are planning, I am happy to help and work with your team. So that's all I have lined up today. It's a brief introduction. The specification got more details. So if you need to find more information, you can go to the specification and then find more information.